So for the notes this week, we're talking about graphing a linear equation, and that's the title of our notes, graphing a linear equation. Our objective is how do I make a graph by identifying important parts of an equation. So if you remember last week, we talked about how to write a linear equation, and we used that certain form. Hopefully you remember, it's called slope-intercept form. And we started by identifying a bunch of variables. So I'm gonna kind of start the same way today. So we're going to look at that form, slope-intercept form, and this is the equation for a line. So we have y equals mx plus b. So let's start by identifying our variables again, just as a reminder. So we have y, and then we have x. So y is your dependent variable. And x is your independent variable. I'm going to abbreviate that one. Okay, so now we have m. Hopefully we remember m. We've been talking about this a lot. So m is your slope. And we write the slope as the rise over the run. Okay, so now let's identify our last variable. Hopefully we remember. B is our y-intercept. Okay, and we also talked about a hint last week. So we know that the y-intercept is that point on the graph where x equals 0. So I'm going to include that again. So we know that x is going to equal 0. All right, so now we're going to use this equation to make a graph. And how we're going to do that is we're going to use a couple of hints to help us remember how to do this. So since we're going to use this equation of a line to make a graph, we have this y-intercept, our b. And if we remember from the In-N-Out activity, the pizza investigation, and then the plant activity, I was referring to the y-intercept as the starting point a lot. And hopefully you guys remember that and that kind of clicked. So your y-intercept is that point on the graph where the line intersects the y-axis. Your x variable always is going to equal 0 at this point. That is your starting point. And so when we're graphing equations, we're going to use this little hint to help us remember. So we're going to think of b, our y-intercept, as the beginning point. So my y-intercept, my b, this constant, is going to be my beginning point. Okay, and I have one more hint for you. So when we think of our slope, or m, we're going to think of our slope as a set of directions. But where the hint comes in is it's going to tell us how to move. So b, your y-intercept, is your beginning point on the graph, and m, your slope, is going to be your set of directions or tell you how to move on the graph. M for move, B for beginning point. So these are kind of little hints to help us remember when we start graphing. Okay, so now let's look at an example. So our example says graph the equation, and we're given this equation y equals negative 3x plus 2. So I'm going to start by first identifying each of the parts in my equation. So it's already set up in the same form, y equals mx plus b, so I don't need to change anything around. But I'm going to identify my slope. So if I look at this equation, y equals negative 3x plus 2, my slope, my m, is always before or connected to my x. So this number here represents m, my slope. And I know that my slope is the rise over the run. So I have this whole number, -3. How can I make that into a fraction to represent the rise over the run? Well, I can make any whole number a fraction by putting 1 as the denominator. So I'm just going to rewrite this as -3 over 1. So this -3, remember my rise is telling me how I go up or down, and since I have a negative sign, that means I need to go down. And my run tells me how much I go side to side. So since this is a positive one, I'll put that positive sign there for you. I know that I'm gonna run to the right. So this is my set of directions here. I'm gonna rise, I'm gonna go down 3 because I have a -3, and I'm gonna run to the right 1 because I have a positive 1. Okay, so I still need to identify my y-intercept. And looking at this equation compared to this one up here, I know that b is my constant, and this 2 represents my constant. So that 2 is going to be my b, my y-intercept. Okay, so now let's graph this equation. So I'm going to use my hints. So b is my beginning point, and I'm actually going to number these because that's your first step, and this is your second step. So my beginning point is B. So I'm gonna find my beginning point on my graph, and I know that I can write my y-intercept as a coordinate, which would be 0, y, or my y-intercept. So let's think of this point as 0, 2, and I'll draw an arrow. So this point represents my y-intercept. So I'm going to go to my graph, and I'm going to go to 0, and then I'm going to go to 2 on my y-axis. So 1, 2. So this is my y-intercept, my beginning point. Okay? So now that I have my y-intercept graphed, I'm going to use my slope as a set of directions to tell me how to move. So I am going to, remember I need to go down 3 and to the right 1. So I forgot to put my marks on my graph. Okay, so my rise is -3, so I'm gonna go down 3, so 1, 2, 3. Okay, so that was -3. And then I need to run 1 to the right, so I'm gonna go 1 to the right. So +1, and then I'm gonna put my second point here. Okay, so I'm gonna do this another time just so that we can see it. So again, I'm gonna start from my second point. I'm gonna go down 3 because that is my rise. 1, 2, 3. All right, -3. And I'm gonna run to the right 1. So I'm gonna go over 1, +1, and I can plot another point. Okay, so now I can connect my 3 points. So hopefully this turns out straight. I don't think it will, but bear with me. Oops, so terrible. Sorry, but you get the point. Straight line, not like mine. Okay, so this equation represents this line on the graph. Okay, so what we did was we took our equation and we labeled the slope and the y-intercept. Then we're gonna use our hints to help us graph. So hint 1 says use B as the beginning point. So I took my y-intercept and I wrote it as a point and I plotted it on my graph, 0, 2. Then I'm gonna use M, or my slope, as a set of directions to tell me how to move. So what I did was I went down 3 because I had -3, and then I went to the right 1 because I had to run 1. And then I continued that pattern until I got 3 points. So now let's check our work. I'm going to highlight this. It's very important to check your work to make sure that you are doing it correctly. So what we're going to do is we're going to take each of these points from our graph and plot them in a table, and then we're going to determine the rate of change. So my first point was 0, 2. There's my first point. My second point is 1, -1. Okay. My third point is 1, 2, 3, 4. 2, 4. Okay, so here's my points. Again, I just took each of my 3 points from my graph and I put them in my table. I had 0, 2, 1, -1, and 2, -4. My bad. Okay. So now we're going to find the rate of change, which we know is written as the change in y over the change in x. So to find my change in y, we should be masters at this. How do I get from 2 to -1? I subtract 3. And how do I go from -1 to -4? Sorry about that negative sign. I totally forgot. Again, we subtract by 3. So my change in y is -3. Okay, let's look at our change in x. How do I go from 0 to 1? Perfect. Increase by 1. And from 1 to 2? Again, I increase by 1. So my change in x is +1. So this rate of change, -3, is the same as my slope in my equation, -3. So I'm going to, so my rate of change from my table, -3, is the same rate of change as my slope here. So this equation represents this line on the graph, and this table of values is the same points from the graph. So this table of value also represents the graph, and this rate of change from the table is the same rate of change from our equation. So these are all the same linear pattern.